Hello everyone, welcome to my channel. Let's solve this question together. Now look at what you are given. You are given that 5 to the power of what? Root x plus 5 to the power of what? Root x equals to what? 80 to the power of what? Root x. We are asked to look for the value of x. Our first step, what you are going to do, we can observe carefully that the power here is root x, the power here is root x, the power here is root x. So we are not wrong in any way. If we let root x equals to any variable of our choice, because root x is what? Common. Let root x equals to what? P. We are not wrong in any way. So anywhere we see root x, we substitute what? P. So that this is what? 5 to the power of what? P in place of what? Root x plus 5 to the power of what? P, okay, equals what? 80 to the power of what? P. We are not wrong in any way. That's our first step. Then our second step, what you're going to do is to divide through by 5 to the power of what? 5 to the power of p. Because you can see that we're having 5 to the power of p here. We're also having 5 to the power of p here. So if we divide here by what? 5 to the power of p, okay? Also divide here by what? 5 to the power of what? P. Also divide here by what? 5 to the power of what? P. Will you all agree with me that 5 to the power of p divided by 5 to the power of p is 1? Plus 5 to the power of p divided by 5 to the power of p is 1 equals what? 80 to the power of what? P divided by what? 5 to the power of what? P. Okay? 1 plus 1 is what? Is 2 equals to what? 80 to the power of what? P divided by 5 to the power of what? P. Now, at our right hand side, let's obey one of the properties of indices. We know that if you have what? Into a divided by b all to the power of n, okay, this is equals to what? A to the power of n divided by b to the power of what? N. If we obey the properties of indices, these properties very well, we can also apply here. You can see that this 80 to the power of p divided by 5 to the power of p is in this form, right? Because the power here is p, the power here is p, and the power here is n, and the power here is n. We can also take it back to this form to become what? 2 equals to into 80 divided by what? 5 all to the power of what? P. We are obeying the properties of what? Indices. Okay. Now 80 divided by 5 will give us 16. So you have that 2 is equals to 16 to the power of what? P. Wow, this is heterogeneous. I love this. Now let's remove this from here quickly. Okay. Now at this point, we can also write this as 16 to the power of p is equals to what? 2. At this point, we are not wrong if we decide to take the natural logarithm of both sides or take log of both sides. But do you know that we can do something very amazing and interesting here? We can put 16 in this form. Remember that 16 in this one simply means 2 to the power of what? 4 or 4 to the power of what? 2. 4 to the power of 2 is 16 and 2 to the power of 4 is 16. Why are we taking this? We are taking 2 to the power of 4 because here the base is 2. So you can easily work with the powers. So we are not wrong. You can also write this as what? Into, we know that 2 to the power of 4 represents 16 and the power of this 16 here is p. So all to the power of what? P equals to what? 2. Right? Alright. At this point, let's also remember one of the properties of indices. That we have what? Into a to the power of m all to the power of n. This law states that the index inside the parentheses can multiply the index outside the what? Parentheses. So what this is what? Equals to what? A to the power of what? M multiplied by what? N. So the same thing would happen here. So this will become what? 2 to the power of what? 4 multiplied by what? P is equals to what? 2. Don't forget that the power of this 2 here is what? Is 1. Okay? 4 times p will give us 2 to the power of what? 4p, okay, equals to what? 2 to the power of what? 1. Now you can observe carefully that the bases are the same. If the bases are the same, we can comfortably what? Equal the powers. That means we are going to ignore the bases and what? Equal the powers. So let's do without the bases, okay? We can see that 4p is equals to what? 1, right? Now for us to have p, and take note, okay, that we are not asked to solve for p. We are asked to find the value of x, right? But if we can know the value of p, we can know what? We can also determine the value of x. So if we divide here by 4, also divide here by what? 4. This 4, we can also add this 4. We see that p is equals to 1 over what? 4. This is the value of P. But no, this is not our answer. Let's recall something very interesting. Remember that from here we say let root x equals to P. Let's recall something very what interesting. Recall that, okay, recall that root x is equals to what? P, right? We know that our P is 1 over 4, as you can see here, right? So it means that root x is equals to what? 1 divided by what? 4. What are we going to do here so that we can remove square root, because our target is to find just x. For us to remove this square root for it, I have to do what? Square both sides. Okay, so if we square both sides, that means this is into root what? X to the power of 2 is equals to into 1 divided by 4, or to the power of what? 2, because we are doing what? We are squaring both sides so that we can have the value of x. This is pocket news. I love this, right? Now you can see that square root cancel out what? Square. We are left that s is equals to. Now remember these properties of indices, that if you have what? If you have into b a divided by b all to the power of what? 2 is equals to, so this is, let me put this as n is equals to what? A to the power of n divided by b to the power of what? N. Now if we obey the properties, if we obey these properties of indices, we can do something very interesting here. So this will become what? Into 1 divided 1 what? To the power of 2 divided by into 4 to the power of what? 2, because we are obeying the properties of what? Indices. Have you seen obeying the properties of indices is very amazing and interesting when solving questions related to them. This is pocket-genius, right? Amazing. I love this. So from this point, we can do what? Determine the value of x. So we know that means x will be equals to what? We know that 1 to the power of 2 simply means 1 times 1, which is what? 1. So here is what? 1 as the numerator, then divided by 4 to the power of 2 simply means 4 times 4, which is 16. So here is what? 16. So we can see that the value of x is what? 1 divided by what? 16. That is case 1 or method 1. Do you know that we have another interesting method we can use to solve this particular question? Now, we can consider 80 to the power of what? Root x. We can also do something very amazing here. We can write it as what? 5 to the power of what? Root x plus what? 5 to the power of what? Root x is equals to what? We can write this as what? Into 5 multiplied by what? 16 is what? Is 80, all to the power what? Root x, right? Beautiful. Let's obey this law, that into a multiplied by what? B, all to the power of n is equals to a to the power of n multiplied by b to the power of what? N. Let's obey these properties of indices. So we're going to have this is root what? Sorry. This is 5 to the power of what? Root x, okay, plus 5 to the power of what? Root x, then equals what? This now become what? 5 to the power of what? Root x, right? Multiplied by 16 to the power of what? Root x, because we are obeying the properties of indices. Now, consider this is common, right? We can now factorize that 5 to the power of root x is common, as you can see, into, if you divide this by this, we have 1. Divide this by this, we have what? 1. X is equals to what? 5 to the power of what? Root x multiplied by 16 to the power of what? Root x. Now I'm going to have this is what? 5 to the power of what? Root x into 2, because 1 plus 1 is 2, equals to 5 to the power of what? Root x multiplied by 16 to the power of what? Root x. Let's divide both sides by root 5. 5 to the power of root x. So divide here by 5 to the power of what? Root x, and divide the whole of this by 5 to the power of what? X. Now this will cancel out this. We are left with 2 equals what? This cancel out this. We are left with 16 to the power of what? Root x. Right? So at this point, we can have that 16 to the power of what? Root x is equals to what? 2. Wow, this is pocket-genius. Now we can put 16 in index form. Remember that 4 to the power of 2 simply means 16, or 2 to the power of 4 simply means 16. Since the base here is 2, we can easily, and we are also comfortable to put 16 as what? 2 to the power of what? 4, right? Because here is 2. Now we can write this as what? Into 2 to the power of 4 represents 16, all to the power of what? Root x is equals to 2 to the power of 1. Because 2 you're seeing, the power of the 2 is what? 1. Now remember these properties of indices, that if you have into a to the power of n, all to the power of n, a to the power of m, all to the power of n is equals to the index inside the parentheses can multiply the index outside the what? Parentheses. So that this is what? A to the power of what? M multiplied by what? N. So that this is what? 2 to the power of what? 4 multiplied by root what? Root x equals to 2 to the power of what? 1. Alright. Now the bases are the same. We can do without them and equal the power. So you have that 4 root x, okay, is equals to 1. If we divide here by 4 and divide here by what? 4. 4 cancel out 4. We see that root x is equals to 1 divided by what? 4. Let's square both sides so that I can have the value of x. This cancel out this. We see that x is equals to 1 divided by what? 16. And this is a beautiful solution to this particular question. Now check method 1 and this method 2. Which one do you find very interesting? Please, if today is your first time coming across this video, don't hesitate to like, comment, and share this video to loved ones so others will learn from it. If you're not subscribed to this channel, please don't forget to subscribe so that you can deliver exciting videos you notify. So thank you so much and God bless you. Bye.